Hello again. So now we're going to approach this problem, okay? Let's read it together. Last year, Karla had 85 attendants. If the number of her attendants increased over this year by 20%, what is the number of attendants Karla has this year? I want you to observe something. Now we're not asking what is the percent of increase. We're asking for something else. So let's read it again. Last year, Karla had 85 attendants. So that was last year. If the number of her attendants increased this year by 20%, I'm sorry. What is the number of attendants Karla has this year? Aha. The before value is going to be 85. And what we're going to be looking for is the after value. And you'll notice I didn't say what the x was because we're going to discuss that right now. But we do want to know notice something else. It's telling us that the number for our attendants increased, and that's going to have an important that's going to play an important role in our interpretation. Okay. So we know that we're going to look for our before, our after, and our x. Okay. So first of all, our before is clear. Last year, Karla had 85 attendants. So that's going to be our before. Okay. Our after is going to be unknown to us. Well, it is unknown to us right now, but it's not going to be unknown for long. But I'm going to let the variable a stand in the place of after. But now we're going to talk about what x is. What did they tell us? So what they tell us in the problem is the percent increase is 20%. And we recall that in the interpretation of the value of x, that in the case of a percent increase, right, the x is greater than 100, and the percent increase is x minus 100, right? So what I'm going to do now is I'm going to take our knowledge of this, and I'm going to set it equal to the 20, okay? Because when it's a percent increase, okay, we know that the x minus 100 is the amount of that increase. In this case, that increase is 20. Now I'm going to be able to find out what my x is. Well, I can add 100 to both sides, okay? And so I'm left with x equals 120, okay? So now I have the three values that I need to set up my standard proportion for finding the percent increase or decrease. Okay, let's do that now. So this is, of course, our standard proportion for calculating percentage increases and decreases. So now let's plug in. I'm going to put my a for the after value, right? My before value is 85. My x, via our reasoning above, is 120. So it's 120 over 100. Okay. So now we're in a position to solve this problem, right? This is our proportion. Okay. And we know from our rule over here that if a over b equals c over d, then ad equals bc. Okay. So in this case, a times d will equal b times c. Okay. So in other words, what's a times 100? Well, that's 100a. That's going to equal to what? 85 times 120. Okay. So now the question becomes, what is 85 times 120? Well, let's do that over here on the side. Okay. So the first thing I'm going to do is I'm going to say, what is 5 times 0? Well, that's just 0. What is 5 times 2? That's 10. So I bring down the 0 and I carry the 1. 5 times 1, that's 5. Plus 1 is 6. Okay? Okay. What is 8 times 0? That's 0. What is 8 times 2? That's 16. I bring down my 6 and I carry the 1. What's 8 times 1? 8 plus 1? 9. Goes here. Now I'm going to add these. The 0, because there's nothing there to add, it just stays 0. 0 plus 0 is also 0. 6 plus 6, aha, that's 12. I bring down the 2, carry the 1. 1 plus 9, that's 10. Okay, okay. So I know that 100A is equal to 10200. Okay, 10,200. So now I want to get the A by itself. I have 100 times A here. So what's the opposite of multiplying by 100? I divide by 100. So I'm going to divide this by 100. I'm going to divide this by 100. And I'm going to get that A is equal to whatever this is. Now, some of you may know that when you have something, whenever you have anything divided by 100, you can move the decimal place twice, like twice to the left from where it ends. And so that would immediately give us the value 102. Okay? But in order to not assume that, I'm going to briefly do the long division over here, just so that we can be fully satisfied, and also so that we can see it as another example of practicing our long division skills. Okay, so let's do that together. So first of all, we can translate this into a division problem by putting this inside the house and putting this outside the house, right? So in other words, 100 on the outside, and then 10,200 on the inside. Okay? Now, of course, for 100, we know that 100 times 1 is 100. 100 times 2 is 200. And so the pattern is very easy to see. In any case, let me make the table anyway, out of an abundance of caution. Okay? So if I have n, and then if I have 100 times n, okay? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now I want you guys to remember, whenever you're making the multiplication table for division, you don't have to go beyond 9. Because the only digits you can put on the division are from 0 to 9. And of course we know that 0 times any number is 0, so we don't have to even put that in the multiplication table. Now 100 times 1 is just 100. Now, if I add 100 here, I can get 2 times 100. Well, that'll be 200. If I add 100 to 200, I get 300. If I add 100 there, I get 400. And so on. 500, 600, 700, 800, and 900. Okay? Okay. So now, does 100 go into 1? No. Does 100 go into 10? No. Does 100 go into 102? Aha. It does. It goes in once. Right? So I'm going to put a 1 over the 2. And I say, what is 1 times 100? That's 100. Okay. So now I ask, 2 minus 0 is what? That's 2. 0 minus 0 is 0. 1 minus 1 is 0. Then I bring down the 0. And I ask myself, does 100 go into 20? It does not. Right? So I put a 0 there. 0 times 100 is 0. And now I perform the subtraction. Okay? 0 minus 0 is 0. 2 minus basically 0 is 2. And then I bring down this digit. Okay? 0. The question then becomes, does 100 go into 200? It does. Twice, right? 2 times 100, that's 200. Okay? 200 minus 200, that's 0. Now, one of the things that I want you to observe here is that whenever I'm doing the long division, like here, okay, I subtracted 100 from 102, and I got 2. I subtracted that, and then I brought down one more digit. I brought down 1 0. And then I asked if 100 went into that 20. And we saw that, of course, it didn't. So that's when I put the 0 there. I didn't bring down this next digit to force it to go in, because that's another common mistake students make. So if you're just very systematic about going one digit at a time, you'll have less mistakes. Moreover, we can see that, in fact, we were right. This number A actually does have the value 102, as we confirmed it by the long division. Okay? And so now we're going to state the result of this problem. So we can state the answer. Karla has 102 attendants this year. I hope you all have enjoyed that example, and I'll see you in soon. Thank you.